Going to talk about trapezoids and the trapezoidal rule today. So we are going to start off with kind of showing why this trapezoidal rule works. So we'll start off with just an arbitrary curve here. Doesn't really matter what it does. Call this y equals f of x. All right, and we will take an interval from a to b as we've been doing. There's a. Let's call b right here. Okay, and then we will take we'll divide this interval into equal subintervals. So let's go here, here. Doesn't really matter how we divide this up. Imagine that they're actually equal. We'll call the distance, actually we'll label that distance in a second. Let's leave that for now. So here's our subintervals, and we'll just sketch those in. When the subinterval crosses a threshold, it gets a little weird, but it's actually not important for the math in the end. So what we're going to do is sketch in trapezoids, where previously we were making rectangles. What we're going to do is connect these subintervals from point to point on the curve, right? And so what we end up with is a bunch of trapezoids, and what we're going to do is try to see if we can't figure out what the formula would be for finding the areas of all of these trapezoids, the sum of them. All right, so this first point here, let's call this point p sub 0. So this point will be at p sub 0, and the coordinates of it will be at x sub 0, y sub 0. Okay, so that's this point here, p sub 0. All right, the next point then we'll call p sub 1. And that will be at x sub 1 comma y sub 1. And this will continue on until you get down here to the point right before the end, right before b, which would be x sub n minus 1. And the point would be x sub n minus 1 comma y sub n minus 1. And then the last point here, which would be just x sub n, okay? And the last x value. All right, so we've got it built for an arbitrary number of rectangles, or excuse me, trapezoids. And what I want to kind of look at here is just remember that our trapezoids, well, first of all, remember the formula for a trapezoid, but our trapezoids are going to look sort of like this. Okay, so we have a base, b sub 2, and then we have the height of the trapezoids, right? Now, our trapezoids are on their side. So like this trapezoid right here, you can see there's our base, there's our height of the trapezoid, here's base, and here's a base. Okay, so the subintervals are going to be the height of the trapezoid. They're going to be the same, so we're going to call those h, okay? If I want to find the area of a trapezoid, we use this formula. 1/2 times the height times b sub 1 plus b sub 2. All right? And so the area of the first trapezoid, so this would be, I guess we'll just write that. The first trapezoid would be equal to 1/2 the height, which we are calling h, and then b sub 1 plus b sub 2. Well, that would be y sub 0 plus y sub 1. Right? Those are our two bases, so let's write that out. Y sub 0 plus y sub 1. Okay, so and we can write this a little bit differently, and I'm going to because that's how the formula ends up. We can just write this as h times y sub 0 plus y sub 1 over 2, although it's really just semantics, it really doesn't matter too much. So there's the area of our first trapezoid. Okay, now if we wanted the next one, we do the same thing, except we'd have y sub 1 and y sub 2. Right? And what we'll do then, to approximate the area under the curve using trapezoids, we will take, I guess I'm going to write it out here, the integral from a to b of f of x dx. If we wanted to approximate that using trapezoids, this is what we would be doing. We would take h times, so take the first trapezoid, right? So that would be y sub 0 plus y sub 1 over 2. Then we would add the second trapezoid, which would be h times y sub 1 plus y sub 2 over 2 plus, and this would continue on till you got down to the last trapezoid, which would have the area of h times y sub n minus 1 plus y sub n. That's the last trapezoid here would have that base of that length, which is y sub n. All right, and so all over 2. Okay, and so now you can see some patterns here. So first of all, there is an h over 2 in every trapezoid, right? So we can factor that term out in front of everything. The other thing that's interesting is that you'll notice that all of the base lengths, except for the first one and the last one, show up twice. So y sub 1 shows up twice. Y sub 2 would show up twice as well, and so on until you get down to y sub n and also y sub 0. Those only show up once. So if we are to kind of simplify this expression here, what we'll do is we'll write, the book uses capital T, I guess, so we'll stick with what they use. So T is equal to h over 2 times y sub 0 plus 2 y sub 1 plus 2 y sub 2 plus 2 y sub 3 plus ... until you get down to the end where you have 2 y sub n minus 1 plus just y sub n. Okay, so there is your formula for trapezoids. A couple things you should remember here. So h, this number is really important. H is equal to b minus a, that's the length of the interval, divided by the number of subintervals, so divided by n. And then the last thing, it turns out that trapezoids are the average of LRAM and RRAM. So if you were to take those two and average them out, so add them up and divide by 2, that would yield trapezoids. Okay. All right. Let's see how this is applied to a particular to a problem, to an example. Okay. So, and we're only going to do one, so this won't be too long of a video here. So let's just take everyone's favorite semi-interesting function, x squared, 4 subintervals, 1 to 2. Okay, and so here is, so if we follow the formula, we need to find h first, so let's find h. H is the length of the subinterval, so 2 minus 1, divided by the number of subintervals, which is 4, so that's going to be 1/4. Okay, now we have what we need for, well, we have mostly what we need for the formula. So the area using trapezoids, we'll call it T, is equal to h over 2, so 1/4 over 2 times, and then it would be y sub 0. So when you plug in 1, you would get, so I'll write that down here below. So 1 squared will give you 1 plus, and then it will be 2 times y sub 1. Now, I guess I'm going to sketch this just so you can kind of see what's going on. So we have x squared, right? So we're going to go from 1 to 2. Okay, so this is at 1, and then this would be at 1 and a fourth, which would be 5/4. And then this next tick mark here, subinterval location would be at 3/2, right? So that would be at 1 1/2, and then here would be at 7/4, and then this last point here obviously would be at 2. Okay, so the height here would be the height of or the length of this base of the trapezoid. This would be y sub 1 in the formula would be 5/4 squared. So write that in parentheses here, 5/4 squared, and that ends up being 25 over 16 plus, and then you've got 2 times, this will be 6/4 squared, right? So that's 36 over 16, and this will just continue on. So 2 times 49 over 16 plus 4. 2 squared is 4. Okay. So then that expression, I did not, for some reason, compute. You can put the entire expression into Desmos, and you don't necessarily need to write this out for like on your paper, it doesn't really matter, or I don't really care. So if we just compute this real quick, it'd be 1 plus 2 times, it'd be 25 over 16, plus 2 times 36 over 16, plus 2 times 49 divided by 16, plus 4. Okay, so 18.75. All right, for the area, the approximate area under the curve. Right, so that's pretty much it for trapezoids. It's just like I said, it's one formula. That's kind of the whole section. You just apply it in a couple of different ways. There are a few problems where we apply this to data, and we will definitely do one of those in when we go over the assignment. But you should, I think you've got enough here that you should be able to at least give a good effort or a good try on those ones where you're presented with some data and you're trying to use the trapezoidal rule. But don't worry, we will definitely clean that up the day after you guys have had some time to work on the assignment. So that's it for 6.5. That's it for Chapter 6.